now. Entonces, negative 25 times negative 25, again, is positive 25. Conclusion, no. The solution for this square root negative 25 is not inside this line, que this line represent real number. Okay, pero no problem. The mathematician create, define by definition, square root negative 1 is equal I. This is symbolic. This is symbolic way to call square root negative 1 instead to write square root negative 1 anytime. No, you put I. Everyone in the world understand case I. Okay, this is definition. So according to the definition, you break it down square root negative 25 like a square root positive 25 multiplication by another square root of a negative 1. And this is clear, okay, fine. And this is clear by definition, okay, and the answer is 5. Then we have, wow, we have another number. You have the classical real number that we working every day, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Not exactly like a fraction, 1/2, 3, 4. Irrational radical 2, pi. This is a real number, the set of the real number. However, we have another set of the number that is called imaginary number. Imaginary numbers. ¿Qué es el nombre que contiene ahí? So real number and imaginary number. So what is the formula? I can't see anything in the screen. Everyone saw the screen, the whiteboard or no?
Yes.
Guys, okay.
Yes.
Okay, so you don't see, you have internet problem. Okay, so you have internet problem, you cannot take the class online. Okay, this is the day of the definition, guys. Like, what is the formula? What is the formula? What is the formula? What is the formula? What is the formula that we use in any time to compute a square root negative any number? Well, it's I times the square root of the positive number without sign. This is the formula. For example, that was example 1. Now example 2 is similar. Example 2 is square root negative 200. Well, I know guess I is square root positive 200. Unfortunately, 200 is no perfect square number like a 25. But you break it down in 2 and 100. And square root 2 and square root 100. Square root 100 is 10. Entonces 10 out, I out, and 2 stay inside the radical, and this is the final answer. ¿Es clear or no? Clear or no?
Yes, it's clear.
Okay, super. Okay,
Yes.
Let me complicate your life a little bit. Suppose now, okay, we have example 3. Well, example 3, I compute square root negative 9 times square root negative 9, 2 square root of the negative number. So now, I know the formula. The formula is que square root 9, negative 9, sorry, is I times square root 9. And square root 9 is 3, entonces 3. And the answer for that part, I know que es 3i. Y the answer of this part, que es the same, it's a coincidence, que es the number, no? I put an easy example now, is 3i. And basically, you multiply 3i times another 3i. 3 times 3 is 9. Y I times I is I squared. So I want to explain what is I squared. See, by definition, I alone is square root negative 1. This is definition. If you square both sides, I'm going to find I squared. I squared is equal, and you know the square and square root cancel out each other because they are inverse operation. No? So the answer is negative 1. Unbelievable. I squared is not imaginary anymore. I squared is real. Is equal to -1. And -1, you replace 9 times -1, it's obvious it's -9. Final answer. And this is obvious. It's obvious because I know using the elementary algebra, the square root any number times square root any number always is any number without radical. In this case, -9, NES -9, and -9 is -9. It's no surprise. This is obvious for me. It's okay, guys? Do you understand this? So let's practice a little bit. How we compute different example. This is the first question in the test 1, similar to this. Example 3. Example 3 or example 4? Example 4. Example 4 is square root -64 times square root -25. Well, okay. Square root -25 I did before. Remember, this is 5i. And this is easy because 64 is 8, no? Pero es negative, entonces 8. 8 times 5, 40. I squared. Y I know very well que I squared, look at that. Important thing, important information. I squared is -1. Okay, therefore, the answer is, this answer is okay, but it's incomplete. I squared, what is I squared? I don't know. Nobody write the answer in that way. You put -40 because I know que I squared is equal -1. Everyone follow me? Easy? Okay.
Yeah.
Let me complicate a little bit. Example 5 and example 6. In example 5, we have 3 radicals. Square root -16 times square root -4 times square root -49. But the answer should be 40 or no -40. No, the answer on number 4 is -40. If you put 40, you are in trouble, big trouble. The answer is -40. What is the reason to get -40? Because I square is -1. Okay? I square is always negative. Yes, -1 specific. I want to explain in detail the power of I after. But I want to introduce this idea que existe. How we compute that? Well, you compute one by one, separately. This, and this using the formula que I explained before. Look at the formula. That formula. What formula? That formula. That formula. Okay, let me highlight that formula because it's important. Extremely important. Okay. So now I compute easy. I compute the square root of the number inside, que es square root 64. But you know, when the number inside the radical is negative, I expect que the answer is imaginary. This is 4i. Multiplication by 2i, multiplication by 7i. Everyone follow me? Square root 49 is 7, square root 4 is 2. So multiplication, 4 times 2 is 8, 8 times 7 is 56. But you have now I cubed. Because we have 1, 2, 3i, I cubed. And who is I cubed? I have no idea. Well, I cubed is I squared times I to the 1. So 2 plus 1 is 3, no? Y I know que I squared is -1, que es real. Multiplied by I is negative. Ooh, look important. Cannot get the I cubed is negative. So what is the final answer, Professor? What is the elegant final answer? One of the elegant final answer is, you leave it like that, no, it's wrong, but it's incomplete. to set down, this is negative 56i. Is the final answer. It's interesting that the power of I, que are even exponent, is real. And the power of I have odd exponent is imaginary. This is a fact. Let me complicate a little bit. Square root negative 36 times square root negative 81 times the square root negative 16 times, wow, too long. Square root negative 9. And we compute separately, one by one. This is 6i multiplication. This is 9i. Square root 81, everyone knows it's 9. This is 4i. And this is 3. And you put in a calculator, multiplication 6 times 9, 54, times 4 times 3 is 640i, 48 I to the 4 power, because we have 1, 2, 3, and 4. And I suppose, the professor explained that when the exponent is even number, it's real. When the exponent is odd, like that, it's imaginary. Try to copy the link and paste it in the is imaginary. It's imaginary. Real, imaginary. Imaginary number. Entonces, bueno, okay, pero I don't know, I am confused. I don't know exactly. Entonces, I to the 4th power is equal I to the 2nd and I to the 2nd, no? Because 2 plus 2 is 4. And I to the 2nd, I know que es negative 1. I to the 2nd again is negative 1. And negative 1 times negative 1 is positive 1. Unbelievable. Unbelievable. I to the 4th power is equal 1. Therefore, my final answer is 648 alone. Real number. Clear or no?
Yeah.
Entonces, this is a moment. If you allow me, I erase the board. I try to analyze in detail the power of I to any power. Well, I know that when they see even a real, when there's all this imaginary, but professor, I am confusing. Okay, no problem. Let me try. Suppose this is the power of I. Power of I. Okay, of course, I want to analyze now because I don't want to complicate your life, only using positive exponent. After I promise I'm using negative exponent. Pero no. Because I discovered that I is equal to square root negative 1 by definition. This is a creation of the mathematicians here. I squared is negative 1. I cubed is negative 8. I4 is 1. Positive 1. Real, imaginary. So you continue to the 5th, to the 6th, but I want to right here. To the 5th power, the pattern is repeated. Exactly. Exactly like that. I to the 6th is negative 1. Exactly like that. I to the 7th is negative I. And I to the 8th power is 1. And so on. Let me repeat again one more column. After I want to explain the formula to any power. I to the 9 is I to the 8 is negative 1. I to the 10 is negative I. Wait. It is 8, 9, 10. Hello, what the hell? Okay. 10 is negative 1. 11 is negative I, and 12 is 1. And this pattern, bang, is repeated forever. Suppose I want to compute I to the 15th power. I continue doing another column. Yeah, you can. But suppose I put 150. It's too long, no? That method is no good. And so I want to discover the formula. What is the formula? One of the formula is, you try. I want to explain two methods. The method 1. A little bit intuitive method. You try to find what is the multiple of 4 close to 15 but down. 1 of 4, 4, look at that, 4, 8, 12, and the next is 16. Because it's the exact multiple of 4. What is the multiple of 4 close to 15 but down? It's 12. If you break it down, 15 and 12 and 3. Because 12 plus 3 is 15. Good. But I know that every exact multiple of 4 is 1. Look at that. 1, 1, 1. It's actually, in my mind, I replace this for 1 because I cube it. But I know that I cube it in my first column, column 0, column 1, column 2 is negative I. And it's the final answer. Negative. I to the 15, which is negative. It's a method 1. Some people like another method, que es easier, in my opinion. Method 2 is divide 15, is the power gets given, divided by 4. Why by 4? Every time click join, okay. But what is the reason guy divided by 4? Because this partner is repeated 4 by 4. I try to investigate what happened when it's multiple of 4. Es obvio que 3 by hand, no en calculator, porque en calculator give me decimal. No good, no useful. Now divided by 3 is the multiplication 3 times 4 is 12, subtraction, and the remainder is 3. So I take the remainder, always the remainder. Is equal I to the third power. You see, bueno, professor, what 3 you take? This 3 or this 3? No. This no. This yes. I want to see another example. Case I negative. I to the cubic is negative. So you divide by 4. Don't worry. Let's do several examples of this until you understand very well the idea. For example, suppose I continue this pattern. In the next column, column 3. Column 3 is I to the 13, que es I to the 14, que es negative 1, I to the 15, que es exactly the thing that we are doing, is negative I. I got it, right? And I to the 16 obviously is 1. Okay? Let's practice. Do you understand? Divide by 4 and take the remainder. That's it. That was example 1 of the power of I. Now let's move into the example 2 of the power of I. Example 2 is A to the 18. Well, I prefer the method 2. We divide 18 divided by 4. 105 too much, 4. Because 4 times 4 is 16. And the remainder is when you subtract in here is 2. So I know that this is equivalent to I to the square. Yeah, I know that I square negative 1. Final answer. Do you follow me? Everyone follow me?
Yes.
Yes. Example 3. I to the 9 power. I to the 9 power is easy. I saw here. But suppose that I have another table, no? Okay. So 9 divided by 4 is 2, 8, subtraction 1. Remainder 1, this is I. I to the 1, no? But 1 is invisible, exponent. It's I exactly this conclusion. Suppose the last example, and that part is easy. Suppose example 4 of the power of I. Suppose I to the 18 power. 18, no, 18, 20. 20. Whoa, what do you expect? What answer you expect? Oh, 20 is weird. Because 20, look, 20 is exact multiple of 4, no? You divide by 4 is 5. 5 times 4 is 20, remainder 0. Oh, so what means this 0? This 0 is I to the 0. The I to the 0 is 1 because any number in mathematics, any number or expression raised to the 0 power is equal to 1. And this is obvious, this conclusion, because 20 is exact múltiplo of 4. Y I know que any exact multiple of 4. So you continue, for example, next column, column 4, we have I to the 17, I to the 18, I to the 19, es negative I, y I to the 20, es obvio que es 1. No secret, es obvio. Entonces, do you understand the formula to find any power of I? This is the second question in the test. The first question, it was the computation several square root, negative number, square root, negative number, and the second is any power of I. Now, let's move on, so you allow me, to go directly to the complex number. Any question, guys? Any question, any question? It's clear? Okay, you make zoom up.
Yeah, it's clear. It's clear.
Okay, you make zoom up. In the React, you put zoom up, click here. Okay, or activate the microphone like this student say, it's clear. Okay, let me try to explain a complex number now. What is that? Complex number, because professor, you explain me real number and you explain me imaginary number, que es the number que contain I. And what about complex? Complex is a combination. Complex is a combination of the real number and imaginary. For example, example 1 of the complex number. Suppose you have this number, 4 plus 3. Oh, this is a complex. Why? Number? Because this number contains 4 que represent the real part and 3 represent the imaginary part. Okay. Every number that we studied before is real, it's just 4. And new thing today was imaginary, but the combination of both is a complex. Entonces we study in detail how we compute the different arithmetic operations using complex number, addition, subtraction, multiplication, and division. Okay? Example 2. Suppose addition first. The addition is extremely straightforward. Look, suppose again this number, 4 plus 3i plus 2 minus I. This is a complex number 1, this is a complex number 2. You are doing addition, plus. Well, you remove the parentheses. In this case, when you remove the parentheses, you have 4 plus 3i, no parentheses, plus 2 minus I. And we combine later. Real and real is 6. 4 plus 2 is 6. Imaginary and imaginary. 3i minus 1i is 2i. End the story. Clear? Super easy. Addition. Now subtraction. Example 3. Example 3 subtraction. It's very similar. Suppose the same number, 4 plus 3i, but are now minus subtraction. 2 minus I. Well, first of all, you remove the parentheses. The first one, you copy exactly the same. But the second, no. Because we have minus in the front, you consider like invisible, -1. And when you distribute this, change the sign. It's a -2 plus I. Again, we combine later. Real. 4 minus 2, 2. Imaginary. Positive 3i and 1i, 4i. That's what subtraction. Any questions so far? Well, 4. Now let's do a multiplication. It's a little bit, not too complicated, but a little bit. Suppose, again, the same complex number, but now multiplication. So when you see parentheses and you don't see any arithmetic symbol here in the middle, you suppose que es multiplication. Default, you suppose que es multiplication. So you consider it, como complex number contain 2 parts, real part and imaginary part, you consider that this is like one binomial expression, and you apply FOIL. FOIL. Multiplication first, 4 times 2, 8. Outer, 4 times negative I is minus 4i. Inner, 3i times 2 is 6i. And 3i times negative I is negative 3i squared. I leave it like that? No, of course no. Because I know that I squared is negative 1, so immediately in my mind, I know that I squared is equal to negative 1. So mentally, you replace negative 1 here. So in the second line, I write a minus 4i plus 6i plus 3. Where come from this plus, this minus, and this minus together, give me positive. Now ready to combine like term. 8 plus 3, 11. 4i negative, and 6i positive is plus 2i. Final answer, multiplication. Consideration, I squared negative 1. Always, when you multiply two complex numbers, I guarantee you, can you see one piece in which you need to replace I squared for negative 1. Okay, so that become real, I combine real and real, and imaginary and imaginary. But we have one special, important special case. A special case, pay attention for the special, because when you multiply one complex number like that, time is conjugate. Conjugate. What means conjugate? Well, it's a family. It's the same complex number. What is the conjugate of this guy? It's 4 minus 3. The conjugate is the same coefficient of the original. This is the original. This is the original. 4 plus 3i, I suppose, no? So 4 plus 3i is the original. When you find the conjugate, this hat indicates conjugate is 4 minus 3i. Likewise, 4 minus 3i conjugate is 4 plus 3i. Now the operation is too easy. The operation is the real part stays the same, and you change the sign of the imaginary part. This is called conjugate. And when you multiply any complex number, time is conjugate, you see two surprises. Two surprises. I want to explain like a ordinary way, traditional way. I want to explain after the shortcut to do in 1 second. Look, you don't know. It's multiplication, and the professor say that you apply FOIL always. Okay. And you FOIL. 4 times 4, 16. 4 times minus 3i is minus 12. Inner 3i times 4 is plus 12i. And finally, 3i times negative 3i is minus 9i squared. Okay. Okay. Entonces, two important things happen here. First of all, the imaginary part is gone. Cancel out always. I guarantee you 100% when we are talking about conjugate, complex number. So the answer is no imaginary, no, do not contain imaginary part. It's just real. Unbelievable. Multiplication, two complex numbers, and they are conjugate. The answer is always real. Secondly, what is the real number? ¿Qué es the answer? Well, no, okay, I replace I squared like a negative 1. Entonces, 16 plus 9 is 25. Final answer. Okay. Entonces, it's weird, but it's important. This is multiplication special. Special multiplication. What is the shortcut, Professor? You talk about shortcut. Well, the shortcut is when you have one complex number, a plus ib. Time is conjugate, a minus ib. The answer is a squared plus b squared. This is a formula. Okay, you don't know, you don't want to memorize. Okay, no problem. Let's do it by 4. 8 times 8, a squared. This and this is minus a, I, b in alphabetic order. This and this is I again, pero plus AB in alphabetic order, AB, minus A squared, B squared. This is cancel out, exactly happen anytime. And the answer is A squared, and remember replace I squared for -1 plus B squared. And this is exactly the same thing. This is the formula. Suppose you don't like the formula, no problem. You are doing by FOIL, and you get the same result. Okay. I want to. For example, let's do an example of this from this conjugate. Example 6. Suppose I multiply 1 minus 3i times 1 plus 3i. Entonces, immediately I detecting, this is the case that the professor explained when they are conjugate. Say, okay, but the professor say that they are shortcut, and the shortcut is you multiply first and first, second and second, because the professor proved me that the multiplication inner and outer always is cancelled out. Look, inner and outer disappear. On 2 is short. Entonces, 1 times 1 is 1. And 3 times 3 is 9. And what sign in the middle? Plus or minus? No, the professor explained it's plus. The answer is 10. Wow, too easy. Okay, so some people now say, no, I don't understand. No, I don't understand. Let's do it by the traditional way. Okay. 1 minus 3i. 1 plus 3i. Multiplication FOIL is 1 times 1 is 1. 1 times 3i is 3i. Minus 3i times 1 is minus 3i. And this is minus 9i squared. This is cancelled. Exactly we expect. And I squared is -1. And another -1 that we have in the front become positive. Got it? Yes or no? Yes or no?
Yeah.
I have one example. Come on. Try to do example 7. You try to do in the way you prefer. And let me know what's the answer. I waiting for you. What is the answer for number 7 and what is the answer for number 8? Nobody? Come on, you are students. If you make a mistake, no problem. Now you can make a mistake. Remember, guys, never change the background of the Skype because I don't want to teach you inside the forest. It's not in my office, okay? What is the answer in the number 7?
Would it be 5?
F5, you are right. Big 5 for you. Where come from this 5, miss? Where come from?
Huh?
Where come from? Where come from this 5? Multiplication who?
2 times 2.
Times 2 get 4.
And then I by 9.
And I times I is I square, ¿no? Pero I square is -1. Pero the professor say que always puts positive.
Yeah.
What about the number 8? No, you, another participation, please.
3.
Es tú, Melanie. Es tú.
Sorry,
Melanie.
2.
Es tú. Where come from the 2, Melanie? Where I come from? Because 1 times 1 is 1, no? Plus, always plus, remember, I times I. I don't care the I care the coefficients here. Okay, 1. And both, in this case, 1. That is the reason that this 1. 1 plus 1 is 2. Okay, perfectly. You got it. Fantastic. Now, in the rest of the time you have, you understand the multiplication very well. Let's do in division. Let's do in division. Remember, guys, everything is recording. Then, after the class, I recover this video and I post it in my YouTube channel. You don't know my YouTube channel, but don't worry because I send the second email with the link connecting with this video. Anytime. So you want to repeat again one lecture, I receive the link and you connect it with the video. Okay, now let's move on to division. Division complex number. Okay, suppose division. M, carajo. Okay. Example 1 of the division. Suppose I want to divide two complex numbers, 4 plus 3i divided by 2 minus I. Okay, this is my original problem. This is my original problem. Okay, the professor wants I do that. So I create here another thing. Okay, is one smart one. Okay, help me to simplification the division always. Create a smart one. How we create the smart one? Using the conjugate of the complex number in the denominator. And my question is, what is the conjugate of 2 minus I? It's 2 plus I. And so you divide 2 plus I by E7. I know that this answer is 1. Now, professor, when I say 1, to say how help me? I help you because when you multiply this and this, the answer is 5, no? Yes or no? 2 times 2 is 4, 1 times 1 is 1, always plus is 5. And so in the top, you apply the same? No, because they are no family. No. You apply the classical form, no shortcut. And you multiply 4 times 2, 8. 4 times I, 4i. 3i times 2, 6i. And 3i times I is plus 3i squared. Something like that. Leave it like that? Of course, no. Remember, in any multiplication, you end in the problem, replace ai squared for negative 1. Entonces es, so far, a plus 4i plus 6i minus 3 divided by 5. Ready to combine like term. Real part and real part. Imaginary part and imaginary part. 10i divided by 5. Leave it like that? No. No. Because any final answer using complex number, you need to write using a standard. A standard form of the complex number case a plus ib. No denominator, no. You split this denominator like that. Look, you divide 5 divided by 5. This 5 divided by the real part and the imaginary part. You say 10i divided by 5. 5 divided by 5, of course, is 1. Beautiful final answer. Any question? Division. Any question? Division, complex number. Okay. Let's do an example. Do the C. Go ahead. Go ahead. Come on, answer me. I don't hear anything. What's the problem is? Using the chat. I don't, maybe your microphone activates sometime, but not always. How do you, okay. She asked me, where come from this 5 in the denominator? Okay, because that was the 2 minus I times 2 plus I. We can do the shortcut. Can you multiply 2 times 2 get 4, and 1 times 1 is 1 get 5. Or, as explained previous time, you FOIL. 2 times 2 is 4, 2 times I is 2I, negative I times 2 is minus 2I, and this is minus I squared. But I know that when you are doing this, always thank you. No. Pleasure. You ask me anything. Always I know that when you multiply one complex number time is conjugate, the answer is real, never is imaginary. Now we have 4, and you replace I squared for -1, and -1 and another negative become positive, and the answer is 5. Now clear? Now clear or confusing? Miss, answer me. Example 2, no? Yes. Suppose 10 divided by 1 plus 3. Division again. What should I do? Compare. What is the methodology? What is the idea? Okay, always it's the same. You need to create a smart one, no? So you put 1 here in the top, 1 here in the bottom. What put in the top is what put in the bottom. The same, because it's a smart one, no? And this is the conjugate of the complex number in the denominator, okay? It's 1 minus 3. Do you follow me? Okay. And this guarantee, okay, when you multiply this times this, the answer is 10. 1 times 1 is 1, 3 times 3 is 9, and always plus. The answer is 10. In the top, no one. In the top is different. It's not FOIL because this is a monomial. Multiply this times this, multiply this and this is 10. 10 times 1 is 10. And 10 times 3 is 30. Right. Can I leave it like that? No. Standard form. The standard form is 10 divided by 10 minus 30 divided by 10. All right. The answer is 1 minus 3. Boom. Final answer. Any question? Any question? Any question? No? I promise to the review package, because before you see in the syllabus, you see before the test, we have two lectures doing something, review, and the test is very, very similar. So you have no forgiveness to fail the test, right? And if you pay attention, so you are every day here with me, you have no problem. Okay, let me spend the last 4 minutes to explain a little bit the power of I again, but using negative exponent. Wow. Power of I, but in this case using negative exponent. Power of I, but with negative exponent. With negative exponent. I need to remember what means negative exponent. Negative exponent is reciprocal. Suppose you have I to the negative 9. I raised to the negative 9. Let me write a more elegant way. Look. I exponent negative 9. Well, I know a negative exponent is reciprocal. This is equivalent to say 1 over I to the 9. This is the only difference. I to the 9, I know how we compute it. 9 divided by 4 is 1. So says 1 over I. I to the what exponent? To the 1 exponent, but 1 is invisible. And leave it like that? No. because I need to write the final answer in standard form. So now I need to division 1 over I. To find the division, you find the conjugate of this, que es negative I. And you multiply 1 times negative I and negative I. Division is a negative I squared. Because 2I, no? I squared. I know that I squared is negative 1, and this negative and this negative together is positive. The final answer in the top is I, and the bottom is 1. The answer is negative I. Boom. Do you see that? So it's similar. The only difference is when you have negative exponent, que negative exponent means reciprocal. Suppose another example. I to the negative 13 power. Bueno, es 1 over I to the 13 power, positive. So flip it, reciprocal. This is called reciprocal. But there's negative exponent, no? The positive, no. Entonces I to the 13 I compute before in one corner of the piece of paper. Look at that. 13 divided by 4 is 3, 12. Subtraction is 1. Entonces this is equivalent to say 1 over I. Okay, but I did before, no? This example, 1 over I did before. Look at that. This example is exactly the same as this. I don't want to repeat this stupid thing. The answer is minus I. So, final answer. One more. The last one, I suppose. I to the 11 power. Minus 11 power. I to the minus 11 power. One is 1 over I to the positive 11 power. 11 power divided by 4 is 2. Because 2 times 4 is 8. 3 is too much. Entonces 8. Subtraction is 3. So this is equivalent to say 1 over I to the cubic power, because the remainder is 3. Look. Y I know that I to the cubic power, I know that negative I, because at least I memorize the first column, the column 0. Remember, the column 0 is square root negative 1 is I. I square is negative 1. I cubic is negative I. I4 is 1. That's it. The first column only memorize. Now, division. Division is conjugate. Multiplication, top and bottom. This is a smart one. So 1 times I is I. And this I did before, is 1. The answer is I. Done. Super easy. So we continue next time working with the complex number. I suppose that we finish. And we start the equations. Okay, including complex number. No? Okay. Let me start sharing. To say, you see me, you see my face now? Inside the photo, no?
Yes.
Inside the photo. I don't like this photo. Please don't change anymore. So let me stop recording